Hey everyone, if you're watching this, you're probably about to take on one of the most intense, challenging, but also insanely rewarding subjects in the IB, physics. And guess what? I'm not just here to talk about the subject. I'm actually a physics HO student myself. So, trust me when I say this, I know the struggle, but I've got your back in this video. I'm going to break down the entire syllabus, explain the topics in plain English, and give you some solid advice for the IA. Let's make the subject a little less scary and maybe even kind of fun. Let's go. First things first, IB physics, like any other IB subject out there, is divided into two subject groups. The standard level and the higher level. Every physics student, regardless of their level choices, are required to learn the core concepts, or as most people say it, the SL content. However, only HL students are required to study the AHL topics, or the additional higher level content, exclusive sections just for us HL students. These are your basics, but that doesn't necessarily mean they're easy in any way. Here's the quick breakdown. The updated 2025 syllabus is organized into 5 big themes. The main idea of the content is not about memorizing a million formulas, which you don't actually have to. It's about understanding how the world works, from batteries to black holes. The 5 main themes start with 1. Space, time, and motion, topic A. This one's your classic mechanics unit, forces, motion, and energy. This section is super foundational, and if you've had any prior physics knowledge of any kind, this theme, along with the rest of the syllabus, gets way easier. Number 2, the particulate nature of matter, topic B. In my own words, most of this section looks at how matter behaves at a macroscopic level. Basically, this is where the knowledge of thermal energy and thermodynamics comes into play. Here, the HL content includes heat engines, entropy, and the laws of thermodynamics. This is where physics meets chemistry, so if you are at the same time taking chemistry like I do, this part will be a breeze. Thirdly, wave behavior, topic C. Now, in my opinion, we are getting to the challenging part of this course. Wave behavior is about how energy moves through space. Here, you are going to learn about transverse and longitudinal waves, superposition, the Doppler effect, and standing waves. HL topics include the Young's double slit experiment, which, for my physics nerds, already know what's up with the Young's double slit experiment. To put it concisely, if you've ever wondered how noise-canceling headphones work or why rainbows form, this is the unit. Number 4, fields, topic D. Okay, in my opinion, we have reached the most difficult section in the entirety of the syllabus. But do not fret, as I will teach you on how to ace your exams in the next section. This unit is all about forces at a distance. You will learn about 3 main types of fields. That is, gravitational, electrical, and magnetic. HL topics go into electromagnetic induction, the difference between AC and DC, and of course, the old Lenz's law. Number 5. Nuclear and quantum physics. Topic E. The last and most mind-boggling unit here. Here's where things get weird and amazing at the same time. To put it simply, this section covers particles and their interactions with the environment. HL topics include the photoelectric effect, wave-particle duality, and the mass defect, which you will solve calculations using Einstein's famous E is equal to mc squared. Now, before moving on to the next section, I hope you as the viewer know that I am explaining these concepts with a heavy grain of salt. I will not be able to explain the full syllabus due to time constraints, but I strongly advise checking the physics subject briefs from the IBO before making any hasty decisions. Now, let's talk IAs, internal assessment. It's worth 20% of your final grade, and it is a 3,000 word investigation essay. based on the research question or RQ of your choice. As someone who has finished it, here's what I've learned. First of all, finding a good RQ is more than 50% of the work done. I took longer time trying to find a good RQ rather than writing the IA itself. Number two, choose something that is measurable and specific. Don't try to aim for crazy topics that go over the syllabus. Simplicity done well equals 4 marks. 3. Graphs, uncertainty, and analysis matter way more than flashy notes. Start early, trust me. My suggestion? Pick something easy that you grab the knowledge of real well. Usually, in most IB subjects, their IAs usually have that one simple topic that you can cover easily. For physics, I would say it's the mathematical proofs of physical constants. Generally, you don't ever want to go for those constants you rarely come across even in the exams. Those constants being the permittivity of free space or the Stefan Boltzmann constant. My IA was the experimental determination of the value of G using different heights of ramps, which to me is a very simple yet effective topic for any IA in physics. Of course, you have to be able to scour the internet for information. The best place for help is Classify, where you can find a multitude of real marked IAs with their annotations. Whatever you do though, make sure you understand it. Do not copy or plagiarize someone else's method. Now, exams. If you are a 2024 or lower year IB student, this section will be shocking for you. Exams have rapidly changed in the 2025 syllabus for the sciences, with the main difference being the removal of paper 3 in the physics syllabus. Instead, it is now only 2 papers, with paper 1 being combined with some content of the section A and the rest of section B of the paper 3 being in paper 2. Paper 1 is a multiple choice question paper with 2 sections. Section A covers 40 questions for the HL and 25 for SL. This paper tests your understanding of core concepts across the 5 themes. Section B is a brand new topic and replaces the old experimental section A from paper 3. It focuses on your practical and data analysis skills, like interpreting graphs, calculating uncertainties, and evaluating methods. So yeah, if you're used to the 3 paper system, this will feel very different. Then there's paper 2, which is where most of your grade comes from. It's a mix of short answer and extended response questions. Basically, where you need to show your full working or structured paper. Here, you will have to explain concepts and sometimes even design experiments or models. This paper lasts for 2 hours and 15 minutes for HL students, and it covers all 5 themes plus the HL content. And yes, options are gone. No more choosing any different or specific topics you excel in or avoiding the ones you don't excel in, such as astrophysics or the engineering physics. One thing to note is that the option of imaging has been removed from this year's syllabus. So everyone learns the same content, and that is what's tested. This change though has some pros and cons. On one hand, it simplifies the content. No more stressing over which option to choose or whether your teacher had time to cover it properly. But on the other hand, it means everyone is tested on everything, including those HL intense topics like relativity or rotational dynamics. What this really means for us as students is that the depth of understanding matters more than ever. You can't just memorize questions or equations. You need to know why they work, how to apply them in unfamiliar situations, and what they actually mean in the real world. Bottom line, The 2025 Physics HLSL exams are more purely conceptual, more skills based, and definitely more focused on making us think like scientists, not just students trying to survive a test. Okay, so now that we know what the 2025 exam looks like, let's talk survival tips. Or better yet, how to actually do well without losing your sanity. Yes, you'll get a formula sheet. No, it won't save you. Just memorizing equations won't cut it anymore. The real challenge is knowing which one to choose, when, and why. In my experience taking the 2025 May exams, the conceptuality is tested on whether you can combine different equations to solve problems. So, instead of just memorizing F is equal to ma, make sure you can apply it to like a spaceship doing donuts around Saturn. That's the IB vibe now. Section B in paper 1 is basically a lab disguised as a multiple choice quiz. You will be staring at displacement time graphs, velocity versus time, all the greatest hits. So, practice reading and sketching graphs until you can spot a trend faster than your teacher spots a pole in class. One tip that I did by myself is that never just do past papers, mark them. Review what you got wrong, write down why, try a little, then do another one. Honestly, this is the only way to train for the IB style of questions. The more you do, the less paper 2 will feel like it's written in Chinese. So, was that fun? Still thinking of Physics HL? I'll be honest, taking Physics HL was not easy. It's a very demanding and challenging subject, but if you lean into the challenge, it is actually kind of fun. Like solving a big puzzle that just happens to include double-slit experiments and space-time curvature. If you're like me, a fellow HL student, remember, it's not just about getting every question right. It's about learning to think like a physicist, to ask better questions, and to actually understand how this universe works. So, study smart, practice hard, and remember, gravity might pull you down, but you've got this.